Hi, Daniel, not Dan. Welcome to Airhacks FM.
Hi, Adam. Pronounced Adam, I'm going with.
Yeah, perfect. And
Wonderful.
Yeah, what was your first computer?
Oh, what a brilliant question. The first computer I used was my friend's ZX81.
Oh,
and it was made of magic. It was an astonishing piece of kit. You had some of those early games. I think Kevin Henney did a breakdown of this. There was a chess game, and the chess game ran in 1K, and it would play a pretty decent game of chess. And there's like whole articles have been written about how this guy managed to get the rules of chess, encoding the rules of chess in 1K is insane. But then building a thing that could actually play a decent game of chess was nuts. Well, I didn't play chess in it. I played 3D Monster Maze, which was amazing.
But the ZX81 was not with the rubber keys. It was one before, right?
Oh yeah, no, it didn't know it had a membrane. It was a flat thing that you just pressed buttons on.
Yeah, it was like
it didn't have buttons. It was just a flat surface that was just printed on.
Okay, I know what it is. Okay, I almost forgot about that.
Underneath the surface, there were little contacts that would be the key presses. And then there's the ZX Spectrum, which came along next in 1982. That had the rubber keys.
Oh, the Spectrum was actually product name.
Yes, yeah. ZX Spectrum was the
Spectrum was ZX. Okay.
Yeah, so ZX81 had 1K of memory, or you could get an extension pack, a RAM pack of 16K that would go in the back. But that meant if you touched the table at all, it would reset. So you're typing in your listing from the computer magazine, and you nudge the RAM pack, and it resets. You have to start all over again. But the ZX Spectrum came with 16K of memory. It was insane. It was so powerful.
Not 48?
Later. They made a 48K version later on. But most of the early games, or all of the early games, were 16K, and a lot of the later ones were as well.
Ah, because I had the Amstrad one, and I could switch between 48 or 128K, I guess.
Yeah, luxury. See,
it looked professional. So it was a serious machine back then. Okay, yeah. What is you started gaming immediately, or you started to implement chess with 1K or half a K?
Oh no! I never wrote any of these things. No, I used to. So my involvement with the computer was either playing games or typing in listings from computer magazines. I have a fun sidebar here, which is that my little brother, who was I think 8 or 9 at the time, started hacking Spectrum games.
How he did it?
I didn't know this. He was famous. My little brother was famous, right? So he would, John, I call him my little brother. We're both in our 50s now, but he's still my little brother. So John would, so there was a little piece of hardware you could buy that plugged in the back of the Spectrum, and you could press a button on it and it would freeze whatever was going on. And then you could get into like an editor, like disassembler thing, and muck around with memory. So you could see, for instance, you could figure out where in memory the number of lives were, or the code, the command in the code that would decrease the number of lives. So like a deck, a deck operation. And so if you you could poke memory, which was setting values, and you could peek memory, which was looking at values.
So your little brother
zero.
Your little brother made me crazy, because in the magazines, as I remember, I bought the magazines and there were the poke values. Like if you do this poke, you get endless life. But I thought, how it is possible that someone knows that? So how they can do this? And then I was not aware of the hardware you're talking about. So this was actually the key. So after, I don't know, I would say 30 years, I know how it happened, right? So there was a hardware which stopped the game, and you could just debug the game, right?
So, well, that came along later. There were other ways of kind of interfering with the game without the hardware, but the hardware made things a lot easier.
Okay.
But the other thing he did, which is what he became famous for, and again, I had no idea that my little brother was this like legend.
Yeah.
The other thing he did was he would crack the security, the encryption on games, just for fun.
But how?
And so, none of this was very sophisticated.
Okay.
This is the 80s, and this is typically kid programmers writing programs for other kids to play kind of thing. But it would be, I know, various bits of bit twiddling that would mean... one of the problems with the early 8-bit games, they all came on tape cassettes.
Mm-hmm.
And the tape cassettes were like, if you've ever heard a modem screeching, the tape cassettes were basically that screeching noise in reverse. So then the computer would take the screeching noise and turn it into the program.
I knew by screeching what is loading. So I could actually identify.
Exactly. Yeah. And you could tell that it was loading the screen part or it was loading the game part. Yeah, and it was like, wee! Yeah. So what this meant was it made it very easy to pirate games because you could get 2 tape recorders next to each other, record on one, play on the other, and now I've got a copy of the game.
Yeah.
And so they started doing things like inserts in the cassette box, and you have a load of codes on the insert in the cassette box. And so then you just photocopy that. So they do like very similar shades of blue on the code, so that when you photocopied it, it just came out grey. So it was just an arms race of like, how could you encrypt things? And his magnum opus was there was one of the Star Wars games came out on 8-bit.
Mm-hmm.
And there was a group of kids. So basically, the games companies, they would go out they have just teams of programmers, and these are all like teenagers, but the teams of programmers who would write the encryption, write the security for the new Star Wars game or whatever. And there was this obviously rivalry between these different groups of hackers. And so my brother's sort of big claim to fame then was there was a group, I think they were called the Haxby Hackers or something, but this group of kids had written the encryption for the Star Wars game. And John, when you used to buy the computer magazines, there was Crash, there was Your Sinclair User, there was different magazines for Sinclair, for ZX81, ZX Spectrum fans. And they would have a cover mount. There'd be a tape cassette on the cover, and it might be a couple of free games or whatever. And John would have a little segment on there, which would be
wow.
his this week's pokes or this week's whatever. And he published the crack to the security for the for the Star Wars game the week before the game came out. And the game came out with this big splash saying unhackable.
Unbreakable Linux.
Unbreakable security. And my brother had pushed out a hack for it the week before.
And what happened? Yeah. Something interesting, or is he? I mean,
oh no. So life went on, kind of thing. He just became a teenager and did other stuff. But then many years later, obviously the stuff.
But were there like reporters involved on someone, because it was a big deal? I can remember back then, right?
Yeah, I mean, no, I don't know. I think it was more like a drop in the ocean. It was more like
okay.
Oh, isn't that funny that that this uncrackable game has got this crack out so easily?
Okay.
I don't think, and there wasn't much litigation back then. People weren't kind of chasing each other; they were just more annoyed.
Yeah, sure.
But much later, there are now like ZX Spectrum fan sites, and all of the games from the public domain now. They're all long out of license, and so you get these websites with literally.
Are they really public, or is still copyright there? You know it? Can you just use the old games?
Yeah, I think pretty much either the companies that own the copyright have long since vanished. I imagine there's still some that are owned in some chain of ownership or whatever. But by and large, no one really minds, what you're doing with the 8-bit, memory dumps. And so he happened across one of these sites for Spectrum games, and he started asking questions on the forums. And then one of the people who runs the site was like, "Are you John North?" Like, yeah. Wow. So he's got this like fan base following from when he was 9.
This was at the WJAX conference. People ask me, "Is it the John North?" And I say, "No, Daniel North." And then we walk out. They exactly. Waited for your brother to explain the ZX Spectrum hex.
No interest in that guy. Where's your brother?
Yeah, exactly. What was your favorite game on ZX Spectrum? Or ZX Spectrum, ZX81. ZX Spectrum was what was your favorite game?
Well, no, so most of the games I played were on the Spectrum. So on ZX81, there was only one real killer game, and that was called 3D Monster Maze. Okay. Which is brilliant. It was a very blocky kind of gidunk frame at time thing where you had to escape from a maze that was randomly generated each time, and you had to not see the monster, which was like a big, very, very blocky looking dinosaur.
Okay.
And if the blocky looking dinosaur got you, you died, and if you got out the maze, you won. So that was fun. On the Spectrum, there were, I'd say there's two. There were many different genres. Obviously, the text-based adventure games were great fun. The Hobbit was a classic. There was one called Leisure Suit Larry in the Land of the Lounge Lizard.
Okay.
There was one called Hampstead. And Hampstead is a posh area of London, and the idea is that you start poor and you have to become posh enough to live in Hampstead.
Okay.
So there were different games, and there were a lot of action games. So it was a really fun game. Computer, a very inexpensive computer that you could play games on, like action games. So some of the very early ones were about a little character called Horace, and Horace did things. I think probably the biggest game on the Spectrum, certainly the one that I've spent many, many, many hours on, there was a series called Manic Miner and Jet Set Willy.
Yeah.
Manic Miner is it's a level game, a platform levels game, and you're this little character and you've got to get through many, many levels. And the miner's called Willy, and you've got to basically get him out of the mine. Through lots of levels. And then the sequel, Jet Set Willy, is that Willy has now got out of the mine and he's now famous. So he's Jet Set and he lives in this mansion, and now he has to wander around the mansion and solve things. So very silly games, but incredibly hard, right? Compared to like modern gameplay, it's really funny. If you go back and look at some of these 8-bit, like 80s computer games, when you sit there and try and play them, they're really, really hard. Compared to like your Zeldas or your, the much more recent games. The gameplay definitely got easier over the years.
What I remember is Ghost and Goals 1, Paperboy, I think, but I'm not sure whether it was on ZX Spectrum. Paperboy was a classic one, I think. Then,
so what you're a little bit later. So these are the 16-bit games. Like this is your Atari ST, this is your Amiga.
No, but it worked on Spectrum. There's Ghosts and Goals, I think, and there was Ollie and something in Shilmore Castle, something like this. It's also interesting. This was definitely on my Spectrum. On Paperboy, I'm not sure.
Fantastic.
Whether I read
Paperboy, I remember was ST. I don't remember. I mean, it may have been on the Spectrum. I don't remember it.
And that was
an arcade clone, wasn't it? That was an arcade.
Yeah. It was arcade clone for sure. Yeah. And Arkanoid. What Arkanoid was like?
Yeah. Wasn't that was big on the BBC, wasn't it? I seem to remember.
Spectrum. I only had Spectrum, and Arkanoid was there. And one was crazy. This was like
there was a company called Ultimate, and they had loads of games. Ultimate had like Attic Attack, Trans Am, lots of games where you had sprites. So someone discovered that you could make sprites move across the Spectrum screen very, very smoothly. So what would happen is every few months or every chunk of time, someone would discover some other really crazy, awesome thing you could do with this little Z80 chip that was in these things. And so graphics generally, screens were slow. They were like, the phosphor, CRT screens. And updates were slow. The thing itself was incredibly slow, had tiny, tiny performance. And so anything that was graphics intensive would tend to go good. And then I don't know the technology of this, but I remember the term, the idea of sprite graphics. And sprite graphics, I think it was something like you could plot a vector and it would just smoothly move them around. But suddenly, almost overnight, all the games became much smoother and all the games adopted this kind of sprite graphics model. And just became really cool.
Yeah.
And you're looking at this, like I say, this 8-bit technology. It's just astonishing what people managed to do with it.
When you started coding, so what was your first line of code, or how you started coding?
That would have been going into WH Smith, which is our high street stationer here, or was, so just recently went under. And that was where that was where they had all the ZX Spectrums on display, and you would type 10. Print Dan is cool, 20 go to 10, and then you'd leave the shop. And it'd be just going up all the screens.
So you were already advanced because you knew about the 10 and 20. A beginner would write 1 and 2, and there would be no room for refactoring.
Well, no, a beginner hasn't typed in hundreds of lines of game code from a magazine. That's what it is.
Yeah. And goes up, right? It was a big deal back then.
Oh, go sub and come back to where you were.
Yeah.
That's insane. That's
Yeah.
so clever. Yeah.
Okay, so you hacked in a shop first just for fun. And what happened then?
Then I sort of got the bug. So I at school I did further maths, A levels, and French as well, because why not?
Mm-hmm.
And then went to university and did maths and computer science because it was an option. I really love maths. I still love maths. And computing then, it was new. It was cool. It was shiny. And there wasn't really much computering.
Mm-hmm.
And so the brilliant thing with the maths with computer science degree, or anything with anything degree, is you get to choose, right? So I could avoid the boring bits. I could avoid the boring bits of maths and the boring bits of computing. And so, the back then, this is late 80s. We started with Pascal. I remember the first code I ever wrote at university. It was a D tab. It was a D tab thing. It would get a line of a file of text, and it had some tabs, and you had to replace the tabs with the appropriate number of spaces.
Okay. This is just tab versus spaces back then. This was the remedy, right?
It was honestly, my university programming career started with tabs versus spaces. It's kind of gone downhill since then. Okay. We'll get into Emacs versus VI later. So Pascal, and then so it was a brilliant degree. So Brunel University in London, and they did, and I still think they're one of the only places that do it. They call it a thin sandwich degree. Mm-hmm. So a sandwich degree, generally you do like a couple of years at college, a year in industry, like an intern, and then final year, and then you graduate, right? But what Brunel did is it was 3 lots of 6 months, 6 months. So you do 2 terms, like 6 months at college, and then 6 months in industry, and you did that 3 times, and then you did a final year. And what that meant is that you had 18 months experience rather than just 12, but also you could go into 3 different places. So you came out with quite a lot of industry experience. And the running joke then was that all the maths you learned at college, and all the computing you learned in the placements. And I had some mad placements. In fact, my first placement, going back to ZX Spectrum, my first placement was for a company called Domark, which I think then became EA Games, or became part of that.
Okay.
In a tiny little office in Wimbledon in South London. And they were doing the 8-bit conversions of what they call licenses. So they take things like the James Bond games, View to a Kill, those kind of things, or the Star Wars games, or board games like Trivial Pursuit. And they would get the license to turn those into 8-bit computer games. And so then they would get little teams around the place that sub out the actual programming. And then they would release these games. And I got an internship with them. And my job for the summer of 1988, was to launch The Empire Strikes Back on the ZX Spectrum Commodore 64.
So it was like a publisher company, right? So what they did. Yeah. So I guess they loved your brother, right?
Yeah, no, exactly. I never told them about John.
Okay. Do you have any brothers?
Oh, the irony. No. North, we've heard that name. No, you haven't. No, you haven't heard that name.
That's a cool story. So you publish Empire. This is great. I mean, this is like a lifetime experience, isn't it?
Yeah. So I published Empire Strikes Back, and then the following summer, my internship was with IBM at Hursley Park, like when they invented the hard drive.
Okay.
And it was like the opposite job. So Domark was jeans, t-shirt, very, very casual, very informal. IBM in the 80s was literally shirt and tie, blue shirts. Everyone wore blue shirts.
Not white, really blue.
So some people wore white shirts. Some of the more out there kind of crazy folks would wear white shirts, but no, everyone wore pale blue shirts. Yeah, it's a very, very corporate thing. And I worked on Kix, CICS. So Kix is the precursor to Link. It's the real-time system that connected all the banks, did all the financial transactions. And I was working on Kix current release. So I went from hacking in C on I started learning C at Domark. So hacking in C and doing support calls for Empire Strikes Back to writing PL1, PLAS, Rex, mainframe execs.
But I use indirectly Kix or Six a lot because there were integration points with JCA Java connector architecture, and there was a CTG, I think. There was like a Kix gateway or CGT
I'm sure
from IBM.
I'm sure there was.
And we had to call it in order to interact from the application servers from Java to host. So this, Kix and IMS back then, I had to interact with the developers, and I was always I was fascinated by the efficiency and complete different architecture how this operates. The thing, right?
I don't know, Kix. I mean, so IBM is so schizophrenic. Like some parts of it are incredibly inefficient and incredibly political and incredibly whatever. And then other parts of it are just astonishing. The mainframe division, the AS400s, OS400s, those folks, the Kix, some of the kind of the more sort of real-time software people were just staggeringly brilliant. I mean, engineers. The engineering behind it was brilliant, but also very, very humble, low politics, try to get work done. And you could see there was this huge tension across the whole campus. There was like you didn't know when you walked into a room which type of group it was going to be. I was wanting bringing this slightly on topic about Java. Of course, and some of your younger listeners aren't going to maybe not know this so much, but J2EE Enterprise Java, which came out in the late 90s, was a collaboration between Sun Microsystems, which got absorbed into Oracle themselves, and IBM. And so IBM was absolutely a tier one kind of almost founding partner of Enterprise Java. So of course they wanted it to interop with AS400. Of course they wanted it to interop with Kix and their DB2, their big mainframe database. Because they had a commercial interest in that.
But this came later. What IBM really wanted to have, and this is one of the earliest J2E APIs, was JMS. Because they had MQ series, and an MQ series. The problem was it was proprietary. There was a Java API, and they implemented they proposed JMS, Java Message Service, which wrapped MQ series. And I remember back then, 2000s, in all insurance and banks, we used JMS to interact with MQ series.
And I used MQ series. It's now kind of probably Watson something, but I think it became WebSphere something at some point. It's been rebranded a bunch of times. But I remember using MQ series like way back in the day, and just how unbelievably reliable it was. Yeah. If you put something in MQ series, it came out the other end, right? Yeah. And so many, even subsequent messaging technologies, I'm not going to name names, but we know that they lose messages. We know they lose audit. We know they are unreliable. And MQ series, another quick IBM praise story. I was working when I was with ThoughtWorks, so in the 2000s, working for a big insurance firm, and they were using MQ series, and we found a bug in what we were sure was our code. We were trying to use IBM WebSphere portal server, which was a horrible technology.
But it's a very good for coffee breaks. So in a company, they used it.
The build, the boot cycle. You got a lot
half
of
an hour.
Yeah. I've never been so slim. I was doing a lot of walking around. So we're using WebSphere portal server, which was an absolute train wreck. But then behind that, we had MQ series, and we were losing messages, and it was really weird. And so it was definitely us, because it's never MQ series, right? And so I wrote a bunch of tests. I managed to isolate it to MQ series, and I was like, "This is really weird." And so, so we contacted the IBM rep. Said, "Look, we think we found a bug in MQ, and it's really unlikely, but we think we have." And they said, "Oh, bluster." And I said, "Well, here are some tests. Here are some tests in Java that we've written that expose that if you do a high lot of concurrency, that it starts returning nulls, and we didn't know why." You
use JMeter, or what do you use back then, or just threads, or?
No, this was JUnit. I think I just wrote a test that would occasionally fail, and wrap that in a thing that ran it 10,000 times. So
cool.
Guaranteed to fail. And so we shipped those tests off to IBM, and then we get it went quiet for a few days, and then I got back. I think it was from Boulder or somewhere. I'm not sure where the MQ team is these days. But we got an email that said basically, thanks for this, right? People never send tests. You're right. We've isolated the bug. Please try this patch. And this was within days, right? This is IBM, the massive, huge, big blue, blah. Within days, the core MQ team came back and they said, try this fix. And we tried this fix and sure, it fixed the problem. And then they issued an emergency patch release globally. And they said, here, we've got this concurrency problem. And I just remember as an engineer, having gone up against big corporates a bunch of times, just how unbelievably responsive they were. We said, we found a bug. Okay, great. Can you prove it? Yes, I can prove it. Well, thank you. That's going to help us isolate it. Yes, we found it. You're correct. Here's a fix. And the whole thing happened. I remember it being less than a week, the whole turnaround.
I was a huge IBM fan for various reasons. The first one was the ThinkPad. To say one time, if I earn some money, I will buy a ThinkPad. And then I got a ThinkPad, and this was the best machine ever. Then it broke, and I got the first Mac. But I was really happy with all the ThinkPad workstations. But earlier, what IBM had, I don't know whether you remember, is AlphaWorks. They had like a website, like maybe like a GitHub something. Not GitHub, it's more like a Java world, like a portal, with really crazy and new stuff. So back then they had agent framework. The egglets from IBM. So there was moving Java code and they communicated with each other. Very similar to A2A from Google right now, but of course pure Java and
were they doing like Java spaces and
this was Sun
blackboards?
This was Genie and Java. You perfect. You are the Java guru. Java Spaces and Genie was from Sun, and Java Spaces was Linda, based on Linda, and Java Spaces was like NoSQL database with transactions, and Genie was like SOA without XML, just native. And with concept of leasing. So if you just disappeared from your framework, it couldn't renew your lease. It was like self-healing. You just disappeared, which was brilliant back then. So they could handle very well timeouts this way.
So it was like a proto bus, but with, as you say, like the timeout protocols and all that kind of the comm stuff layered on top transparently.
Yeah. And it was used by the Army. It was used by McLaren, Formula One. So it was
super reliable. Yeah.
Yeah. But it was hard to configure. So it was like the DSL was hell on earth, but it was actually. And the next one, which I used in project, was Jaxta, was even more interesting. Juxtapose was peer-to-peer technology. So you could have peers which communicated with each other, very similar to agents again. But back to IBM, they had a very fast Java compiler called Jix back then.
I was about to say, I remember Jix. Jix was made of magic.
Yeah,
like Jix compared to Java C was like, what are you doing? What
are
exactly. They doing in there? That's so clever. Yeah.
Then
and they had their own JVM as well, didn't they? They had IBM JVM.
But
Jix, and it was just the whole thing was insane.
In the year 2000, I don't know how they did it, but or 1999, if you went to Java 1, you got Palm Pilot, and on this Palm Pilot there was the JVM. I hope it was from IBM or from Oracle, not from Sun. I guess from IBM. So it was very small JVM running on Palm Pilot. Maybe it was from Oracle, but I think it was from IBM. And they did lots of crazy stuff back then. So I was huge IBM fan. And I even liked the Visual Age for Java. The only what I didn't like about that is that you never was able to see the entire source code. You were forced to see a method. There was no the source code because it was a database basically. But I like the look and feel of it.
Do you know why?
Yeah, but it's just database, Envy, right? Envy database. So there were no source code.
No, it wasn't. It wasn't that. Visual Age for Java was a port of Visual Age for Smalltalk.
Yeah. Mm-hmm.
So Smalltalk doesn't have files. Smalltalk has an image, and the image just contains classes, contains objects. And if you want to change your editor, that's built into the image. So you just change the editor because that's just more classes. And Java was now one of the design choices, but I would say one of its greatest weaknesses was the coupling of class names and package names to files and directories. And that meant that now, you as a developer, you were exposed to, you couldn't not know about the file system. You could not know about and of course, and then that meant that you needed things like Visual Age, which became Eclipse, or IntelliJ, because something logically simple like renaming a package is. So let's think about what happens when you rename a package. What do?
It was impossible back then.
I need to take I need to take an arbitrarily deep directory hierarchy containing arbitrary files. I need to create the same hierarchy but with a slightly different name somewhere in the path. Right. I then need to recursively copy all of the files from one to the other and make a tiny change in them. I'm not just moving them.
Yeah.
I've got to find the package line. I've got to change, and I've got to make that look atomic. Oh, and I've got to clean out all the other stuff that was there, and I've got to make that look atomic. I mean, no wonder you couldn't do Java development in VI or whatever.
JBuilder couldn't do this. JBuilder couldn't do this. Visual Age could, but Eclipse did it better. So actually, Eclipse was the first one which really was able to refactor. I was a huge fan of Eclipse back then because you could
NetBeans was pretty cool back then as well.
Yeah, but it was a bit strange because NetBeans until 5, you had to mount jars. It was like strange. This is why. And it was like I couldn't understand that. But then I think with 5 I became a huge NetBeans fan, and NetBeans had very good refactoring support. And I still from time to time use NetBeans because it's a little bit faster than Visual Studio Code. Interestingly, so if you open NetBeans and edit something, you see how fast it feels. And Visual Studio Code is okay, but it's a little bit slower. So, but back to you. So your second seminar during your study at IBM. What you did there?
Yeah,
second year. So what you worked with Kix, and you had assignment or just learn about Kix?
Honestly, I don't remember particularly. This is 40 years ago.
I thought 10 years ago or something. We are young,
I posted something on Mastodon last week and upset some people. I said, if you're a child of the 80s, hearing someone talking about the 80s now is like when you were a kid hearing someone talking about the 1940s.
Yes, but what my impression is, I'm really curious about your opinion, that the innovation actually slows down. It's still crazy fast, but it's not like big leaps. There are incremental improvements very fast. But I would say 30 years ago, in all areas, everything was improved. The synthesizer was invented. We get computers. Cars went better. There was smaller diesel engines, more efficient. I don't know. Carbon fiber was invented. Then internet was everything on all areas. Everything was improved. And now we actually everything is not only improved, it is made more efficient, which is a little bit more boring because it's no more as good as it should be from my perspective, and it doesn't move that fast. Is it also your opinion, or?
I think there's a wonderful Douglas Adams quote, and it says something like, "Anything that's invented before you're 15 has always existed. Anything that's invented between 15 and about 35 is cool and amazing." And anything that's invented after you're 40 is weird and has to be stopped.
Okay. But it's not that much invented out of the last 10 years, if you think about this, right? If you compare our computer with computer, 5-10 years ago, it's okay, it is nice and everything, but it's not like huge leap. Even if we have now M series of Macs, and back then we had Intel, okay, it gets hotter, but it's not like a big leap, like between, your ZX Spectrum 81 and my ZX Spectrum was huge, was 128 times improvement, you know what I mean? And it's not like quantum computer may be the next big leap because of something different. It means in all areas, the technology advanced, but we still don't have, fusion, for instance.
I mean, but that's always going to be the case. This is why people are so desperate to shill LLMs as a path to general intelligence.
Yeah, but they also stopped, right? It's not like the ChatGPT 5 is orders of magnitude better than 4.
No.
Right? No.
And my controversial opinion is that we're chasing the wrong technology. But there's a $1 trillion bet on the wrong technology. So a bunch of people are convinced that you have to make it work. And
not with brute force. I think maybe this brute force approach with hardware is the wrong one. And
but I think I'm going to push back a little bit. I mean, I drive an electric car. the concept, the very idea of owning or driving an electric car 10 years ago was like completely out there.
Mm-hmm.
Whereas now, having driven, I've got two actually, having driven electric cars now for some years, I absolutely would never go back. What I have is a massive iPad, two huge hairdryer motors, and wheels on the corners.
Yeah,
like that's the whole car.
Yeah,
and you're thinking about internal combustion engine with lots of tiny little explosions popping up and down, and then a thing turning that into rotational energy, and that turning that into a different the staggering inefficiency of that.
Yes.
And the number of literally moving parts and things that can go wrong is just mind-boggling compared to a big fat motor and a big fat battery.
But electric car were always possible, right? I mean, the
yes
battery
no.
was...
So the theory's always been there, but the innovation that means that I can now get a battery that is small and light enough to put in a car and can drive that car for 300 miles, 400 or 500 kilometers, and also the infrastructure that means that I don't have to drive for 500 kilometers. I can drive for 200 or 300 kilometers and charge that battery in 20 minutes. Mm-hmm. So there's been some staggering innovation in that space. The shift from, you say these things haven't moved. I mean, the shift from mobile phones, which were amazing and cool in the 90s, mm-hmm. with just, 1G and 2G voice over phones was really clever. Mm-hmm. To now routinely streaming HD video on a cell phone, on a screen that's this big and is OLED, HD quality screen. Yeah. So I think what's happened is you and I, because we're a little older, we've gotten complacent about this stuff. Mm-hmm. But I do think when you stand back and look, it's mind-boggling, the stuff that's going on. I think the real innovation isn't getting the press. I don't think the problem is that it's not getting the airtime. Maybe. Again, the LLMs, and last week it was the NFTs, and the week before that it was the blockchains, and the week before that, whatever they're shilling now, right? Yeah, that's the stuff that gets all the airtime. Quietly at the sides, there's incredible innovation going on, and it's just not getting the visibility.
Mm-hmm. I mean, so the SpaceX, how I don't know what's the name of the rocket is able to land on a pod. This is big deal. If you this is crazy that it can reuse that thing. And you're right. You are right. I mean, a smartphone is incredible technology. I mean, the antenna alone in the communication and the bandwidth. But if you were born 5 years ago and you see your first, your iPhone or iPad, there is no reason to buy the next one. This is not like this is what I mean. A few years ago, the entire technology stack was not as, or even what you said is, if you was let's say in your 50s in the 80s, and you looked 40 years back, there was almost nothing. There was no television and nothing, and then it happened, and it was very fast, and now it gets more perfect. But between my iPhone and the iPhone 1 or iPhone 3, right, there is a difference, but the concept are the same. It's just incremental improvement. This is what happens.
No, I agree with that, but I think again, you do get the step change. So I've had we're going back to the Lenovo, or IBM ThinkPads. Mm-hmm. I had a ThinkPad in the probably 2010 or so. Mm-hmm. Absolute, tricked out ThinkPad running Linux, and then like you, I moved to Macs. I remember I've had two wow moments with Macs. When back in, I should go about 10, 15 years ago now, the MacBook Air, the little 11-inch MacBook Air, mm-hmm. when that came out, I was like, this is the most amazing bit of technology I've ever seen. Mm-hmm. I was doing a lot of flying at the time, and you can sit in economy with this tiny little thing on your lap, and it's a full powered computer, and it would last for 6-7 hours on a battery, mm-hmm. which back then was unheard of. Mm-hmm. And then again, it was incremental and a bit crunchy and whatever. And then suddenly the M series, Apple's system on a chip, came out, and it really was night and day. I had such a wow moment when I got. I'm still running. I'm talking to you now on an M1 Max. Yeah. I've had it since for 5-6 years. I'm not going to update until. They're talking about completely changing the form factor and the screen and whatever else. Mm-hmm. This thing is still a beast. It's a 5-6-year-old computer, and it's still a beast. So that architectural shift, and again, you can only do that when you have full vertical integration, when you own the entire stack. So they changed the OS, they changed how memory works, they changed how applications do time sharing. Like, so a huge amount of software changes under the hood enabled this astonishing hardware.
But it's not as big change as between ZX81 and 2 years later, my ZX Spectrum 128K.
Well, here's the mad thing: is what's old is new again. So what they're really doing is rediscovering the RISC chips from the 90s, like your
alphas,
DEC alphas, right? I remember I used all the Unixes, right? So HPUX, AIX, SCO, and I remember using DEC alpha because digital equipment called DEC. They were famous for VMS, so they had the VAX VMS systems. And then they introduced this Unix, but they were the first company to introduce a full 64-bit Unix. So 64-bit CPU, 64-bit backplane, 64-bit memory. And this thing, it was spooky. I remember feeling you would type something in and it would come back almost before you hit the enter key. And you go and use any other Unix. I mean, HPUX or AIX or IBM's one was just so sluggish in comparison.
Yeah.
And they went bust. They went bust because because commodity hardware is much cheaper to scale than exotic big hardware. Same reason that the Spark, the Sun Ultra Sparks went away. Sun hilariously produced this technology that made all of their hardware redundant. Then went, oh well, no, we're not making money.
Yeah.
But the Intel one, and so the Intel model, the one, and then suddenly now we're rediscovering with reduced instruction sets. You can get a lot more for your silicon wafer. You can put the memory physically on the same wafer as the CPU, as the back. All of that is your SoC, the system on a chip. But that only works when you have a massively reduced CPU complexity, because then you've got room for all the other stuff. And so we're rediscovering RISC, and it's delighting me.
Yeah. But you know what I mean, right? This was more exciting, big news back then, maybe for us, or maybe not. And now I don't think whether the youth is so excited that they get they switch from Intel to M. I think.
No, I think you're right. I think a lot of it as well is fatigue, right? It's kind of like an innovation fatigue.
Yeah, you're right.
That, like we would hear about these things, or we might start a new job. Like I came across, I'd never heard of DEC Alpha. I started working for a big French bank, and they had this brand new technology, digital alphas. I was a Unix guy. They knew I was a Unix guy. I was in my 20s. They said, "Oh, you're the Unix guy. Come and take a look at this." And I fell off my chair. But I didn't, no one was spamming me on a mail list with it, or, shoving adverts in my face. I came across it and had a really pleasant surprise.
Yeah, this is maybe the reason.
So I think there's an information overload thing. Yeah. Is the signal to noise is just terrible. Back in the day, at the risk of kind of get off my lawning, we had social media. It was called Usenet. And there were news groups, and you would subscribe to news groups, and you would contribute to news groups. And I learned all of my C on CompLang C, and all of my Unix on Comp Unix questions, Comp Unix wizards, CompLang C++. These very, very welcoming communities, where people would ask questions and people would get answers and people would learn. And, you got the occasional pompous, you have to go and read the FAQ type of thing. But by and large, they were just very welcoming communities for geeks to go and learn stuff, and there weren't, this was long before the web. This was the internet. The internet started in the 70s. The web started in the 90s. So this was that gap in between where we didn't have access to, there wasn't a Stack Overflow. There wasn't a, like you say, there was, even when the web was young, we had things like IBM's AlphaWorks,
which is in trouble right now. Stack Overflow. This is big trouble,
right? Because of AI slop, right? Because of people aren't going there because they're asking ChatGPT to summarize it incorrectly for them, and they're going,
exactly.
I don't know if you've heard Tailwind, the CSS library. the guy who runs that, he's basically shutting up shop. He's saying, we're no one's buying our licenses anymore because you're just getting, Claude is doing your Tailwind for you.
Mm-hmm.
You don't need any of our expertise. And so, you're getting the Ouroboros where the snake's eating itself. And I don't know where the business models. I don't know where the business models go from here.
Mm-hmm.
I think it's heartbreaking that someone who's built this amazing thing, tried to build a commercial model around it, is then just saying, "Well, I'm done now."
Mm-hmm.
That makes me sad because it suggests that the person who's building the next one of those is going to look at that and go, "Oh, I might as well not bother."
But I think what will happen is...
Actually, no. I now have an answer for you, Adam. One of the things that has happened again and again in my professional career in the last, and it's not slowing down, is incredible innovation in open source.
Mm-hmm.
Every 5 minutes, I see a thing, and someone said, "Oh, I've just built this new open source thing that's going to scratch an itch that you had," and I'm like, "Wow."
Mm-hmm.
Thank you. I don't know if you do anything in Python, but there's one of the Rust folks, there's a company called Astral. They've written a thing called UV.
Mm-hmm.
And UV it replaces the entire Python toolchain, your pip, your poetry, all these different things. It's written in Rust, and it does in milliseconds what pip and poetry would do in minutes. I mean, it really is insane.
Mm-hmm.
So when you create a virtual environment in Python, you're creating a directory structure and a load of symlinks and a whole bunch of stuff and importing. It will do that sub-second.
Mm-hmm.
That would have been a 10-second thing where you sit there and wait for it to build your virtual environment. Mm-hmm. And so, there's cross collaboration between these communities. So, the Rust folks aren't going, ha, we've got a really cool tool chain. They're looking at Python and saying, you can have a really cool tool chain called UV. And then some Ruby folks have now got UV envy from Python. And they've got a thing called RV, which is the same idea, but for Ruby. And people are looking around all the time saying, we can make this better.
Mm-hmm.
I mean, go on, sorry.
You are right. What I meant is not just software or IT in general. So, back then, music instruments, the entire synthesizer and so forth. Then in parallel, computers. In parallel, cars. In parallel, TVs were, transformed. So it was like, cool stuff on all fronts. And now seems like computers won, and everything, whatever you touch, your car is a big computer, everything a big computer, which is a bit boring for me because I know what to expect. So I would say, quote. If I get electric car, and the most you can get is a really good iPad, because I don't think Tesla will be able, for instance, to make a better iPad than Apple does, right? For instance, it's almost impossible. So what the maximum you can expect is an iPad on wheels. And lots of stuff is not needed in the car, right? It's not like all these services are essential to driving, and I don't know if they're helpful. And maps, of course. The navigation is amazing. This was, but it happened, I think, on my Nokia. I had already navigation. It was very early, before smartphones, and now it's incremental and better, but it was good enough. And I had done, I don't know, 20 years ago, an old Volkswagen. There was DVD-based GPS system, so I had to load, the map. But it was amazing. It was good enough, I would say. It didn't look amazing. So I would say there's not a huge difference between my, it's not like way better experience to using my colorful navigation system from now comparing to back then. And in our youth, there was amazing stuff. Even in tennis, they knew how to call it from carbon fiber skis on all areas. Everything was, there were big leaps everywhere. And now, if you compare ski or whatever you have, a guitar or whatever, with something which is 10 years old or 15 years old, it is not a big difference. So it gets better and better incrementally, right? And back then everything improved on all fronts. Even coffee machines, whatever you looked back then, you know what I mean? This was like a big revolution on all fronts, because new materials were invented, because maybe by computers. And with that were new possibilities. And now maybe with LLMs, if they work out, we will see something similar, hopefully. because LLMs could be the next big leap, new materials, whatever, stuff which was not possible before, maybe.
So in lean terms, they use these two words, Kaizen, which you may well have heard of. Kaizen is continual improvement.
Yeah.
The one that a lot of people haven't heard of is a thing called Kaikaku.
No.
And Kaikaku is an abrupt change.
Mm-hmm.
And so Kaizen caught on in the West because we do like a Japanese term. And we talk about continuous improvement. But the whole point of Kaizen is that it only works in conjunction with, like a yin and yang thing, in conjunction with Kaikaku.
Mm-hmm.
So Kaikaku says, let's look over there.
Mm-hmm.
We've done as much as we can here. Let's look over there.
Exactly.
See what's there.
Yeah.
And sometimes looking over there doesn't work out. Sometimes looking over there is amazing.
Mm-hmm.
But we look over there and we start a new thing, but we're rubbish at the new thing.
Mm-hmm.
So we've got internal combustion engine cars. Let's look over there at electric cars.
Exactly.
The first electric cars we built were really inefficient, really heavy, really slow, really crappy.
Mm-hmm.
So that was the Kaikaku. And then the Kaizen is the continual improvement of that.
Yeah.
And what happens is, you get these cycles. You get a cycle of, Kaizen of phones was, we used to have operators in a room that would connect the calls, patching you through, Adam. And then that became automated. The Copenhagen telephone exchange, famously, with the Erlang switch, that's been running for 30, 40 years now and has never had any downtime. So that's as much Kaizen as you can have with a fixed line phone. Is that now we have very good call quality. We can make international calls. We don't need human in the loop. And then someone says, what if it didn't have a cable? What if you had a device that was like a walkie-talkie? We've had those for decades, but a walkie-talkie that connected to the phone network somehow. Whoa. Right, that's your Kaikaku. And then we spent the next 30 years, 40 years getting better at that.
Yeah.
So you're right. I think what we have lived through a period of intense Kaizen in a load of things that were sort of invented in our lifetimes.
Yeah.
And you're mourning the Kaikaku. You're saying, yeah, but no one's coming up with the next crazy thing.
Exactly. So my impression is in the 80s, there are lots of Kaikakus or synchronized Kaikakus over all disciplines, if you think about it.
Right, exactly. They were cross fertilizing as well.
Exactly. So there was like a sync point and there was Kaikaku everywhere. And since then we have Kaizen, which is cool, but Kaikaku was exciting, right? Because it was, even the new thing, it didn't work better than the old thing, but it was new.
Yeah.
So this was, how to call it, the video recorders, right? This was the same. We get the first video players or video recorders, or how we call it. And beta was better than VHS, and then was incremental improvement until they disappeared. But the first one was amazing that you could record television. It was right. It was really amazing, and But
and movie rental. Well, once we had videos, we had movie rental. It created an entire new industry.
Yeah, exactly.
Netflix started as postal movie rental.
Yeah, but between a movie rental and Netflix, okay, the same concept, It's not like as amazing. So you can imagine that I was actually sad a little bit is okay because, the Blu-ray had good quality and then the streaming had less, or I think still is. Blu-ray is still better, I think, than streaming. And but you know what I mean. So, but what I'm interested, what was your third assignment or the third year? So you were at IBM. You revolutionized, you were a game publisher, Kicks hacker, and the third one?
So, I need to confess here. So what would happen is this. Bruno had a brilliant, assignments board. So the idea was you'd go to this assignment, and they were coming up every day, these assignments. So there was a whole team of people who would help your students get these assignments. And, and you go to the board and it'd be Oracle or IBM or Fidelity or big companies or, that were going to hire some students. And you would rock up with your CV in a suit and have an interview. And I basically, I spent the first year at university drinking and forgot to get an assignment. And then it came up to Easter and you had to go and do your assignment now. And so that's how I accidentally ended up at Domark, is I picked up the phone book, opened up C for computing and just started dialing all the numbers saying, do you want an intern? And I got down as far as D and they said, yeah, we could use an intern. So that was very opportunistic. The second year, I was much more disciplined. Did all my interviews and ended up at IBM.
So what you learned from that is don't be too disciplined, right? So your first year was more exciting with your strategy than the second year, right?
Well, and it turns out that my third year I regressed. I failed to. No, what it was, I don't actually remember how it happened, but I ended up working as a contractor for a couple of guys who were designing the control software for X-ray machines.
Wow. This is quite a progression, I would say.
It's a bit crazy. It was in would now be called Delphi, but then it was Turbo Pascal. Turbo Pascal was an object-oriented version of Pascal that ran on Windows PCs, Microsoft PCs. And it had its own IDE, it had its own runtime. And Turbo Pascal was actually a really cool language. And so I was doing digital image processing of X-ray images in Turbo Pascal on, at that point, state-of-the-art IBM AT or XT or whatever machines, whatever they had in 1990. So while one of my buddies who was doing government and politics degree, she was doing an internship in Germany and was in Germany when the wall came down, I was on campus because it didn't matter where I worked because I was remote. And so I was sitting I was sharing the office of my maths lecturer, my maths tutor. And I would sit on a little desk that he had and I would be hacking away on my IBM AT machine or whatever, writing X-ray control software. And that was my summer, and it paid really well because they were basically paying contract rates.
But how you could do this? Because you were new to Delphi or Turbo Pascal, or you are already skilled Turbo Pascal or Pascal
so
developer?
I don't remember how. No, I think they needed it, so I taught myself.
Okay.
I think they said. In fact, funny enough, my first job as a graduate, 1991, I joined as another image processing thing. Weirdly.
So you had to process the X-ray images, right? So you had to parse or
Yeah, I was. What did it do? I'm trying to remember what it did. Yeah, it would receive an image, it would display an image, and it was looking for things on the X-ray. I think it was looking for objects on the X-ray, and it would try and find boundaries. So this is a very early AI, I guess, very early. It's like machine learning type stuff of trying to figure out where the objects were in an X-ray. And then being able to put a few X's on there to say this is an interesting part of the X-ray to look at.
And it worked?
So that was my...
Something?
It was pretty cool, yeah.
Incredible. So, and what happened afterwards? So, you started after university, I guess, right? So what happened? You started to work for whom, or were you independent, or?
Well, so I graduated in 91 in the summer in the middle of a recession in the UK.
Okay.
So I had a 2-1 honours degree in maths and computer science. I had 18 months work experience and I couldn't get a job. There was nothing. And so I was unemployed for I claimed unemployment benefit for 3 months. And I was doing all the things you do when you're trying to find a job. So, and at one point there was a jobs fair, as an annual jobs fair in Islington in North London. And I went to the Islington job fair. And it was exactly what you'd think. It was this huge, huge space with lots and lots of companies with little stalls, and you'd go and hand in your CV or whatever. And they're all just the same thing again and again, banks, insurance, telcos, all that kind of stuff. And I've been there the whole day and I've handed out tens, possibly hundreds of copies of CVs. And it's just really desperate. And I'm just like, none of this is going to. And it was the end of the day and people were starting to pack up. And there was like an upper sort of perimeter area, like an upper balcony. That was the cheap seats, right? So I thought, I'll go up and have a look at the cheap. So I went up to the upper balcony and everyone's starting to pack up. And this company had some really cool photo images up on their walls. And I said, oh, this is really cool. What's this? And they said, oh, this is what we do. We do, it's called electronic pre-press. And so the idea is if you're a publisher, if you're a newspaper publisher, you publish, or a magazine publisher in color, you would have these massive plates that you would print for each page of your magazine. And you would print 4 plates per page, which has cyan, magenta, yellow, and black. And they would go onto these big rollers, and you put them in the ink, and then you put it onto paper. And
this is where CMYK coming from, right?
CMYK comes from. And so and this was and that was when you would find out that the color was wrong, the position was wrong, whatever else. It's a very expensive way to find out that you've got the color wrong. And so this industry grew up called pre-press. So this is before you go to press. How do you test your images? And around this time, Canon had just invented the color laser copier. It was a brand new innovation. And so
see, this is what I'm talking about.
There you go. It's called a color laser copier, Canon CLC. And so this company was a joint initiative between Fuji and DuPont. So Fuji obviously make film.
Okay.
DuPont make chemicals. And could we use this color photocopier to generate the same colors that will come off the printing press when we make the plates? Because if we can, and the colors are wrong, it's much cheaper to correct the image then than it is once we've printed, spent a lot of money. And so the most of the job was, if you imagine a 4-dimensional cube where you take a color value, a CMYK color value, which represents, mid blue or something, and you're going to put that through a 4D transform to get another CMYK color value, which is the color you must print on the Canon printer to get the equivalent color on paper.
And because the calibration of the Canon printer is different to the other one, or why was the transformation?
Yeah, exactly. So the colors that you have in your, it was a TIFF image file. And the colors you had in your TIFF image file would map to skin tones or whatever it was for the photos. And if you printed those straight on the Canon color, you'd get one color. If you printed them on magazine paper, you get a different color. And so you had these folks who were color experts, chromatography experts, and they would come up with these mapping cubes, mapping algorithms for saying, well, okay, well, these colors on paper, you need to do this to them to get the equivalent color on the Canon printer. And so that was my job. My job was, it was a huge C code application that would take in image files, take in a big color cube, transform them through the color cube, and emit the new image file that you could then send to the Canon printer to get your print.
This is the entire image file. I thought you just, adjusting the colors, but you have to adjust every pixel.
Yeah. So I've got to take the cube, take the image file, and this comes out as a photo of a model wearing a whatever in a magazine.
This is how you started Adobe on Photoshop, right? This is.
Well, so I'll tell you what they did. Where it did start, there's one of the core technologies in it. It's called a RIP, a raster image processor. So the RIP would take the color, the raster image, the color, and it would do then the transformations and produce you a TIFF file. So it would take a TIFF file and produce a PDF, I think, or it was a TIFF file and produce another TIFF file. But basically, so this idea of a RIP was pretty new, and some of the folks at Crossfield, it was called, this company, they wrote a custom RIP, and then they went and started their own company, which licensed this RIP to folks like Adobe. So that's where a lot of their early image processing came from, was out of these little R&D centers like this Fujitsu DuPont thing. And I just lucked out in this first job, and then I had a sequence of totally random jobs. I went to
and you had to write a RIP from scratch, or you just co-implemented the RIP?
So some other folks wrote the RIP. I was working on I did the part that took the image, and transformed all of the colors through the color cube and to produce a new image.
Yeah, but this is almost just the 80% of the entire thing, no?
Yeah, pretty much.
Yeah, what the others did? I mean, what's left?
Well, no, I mean, I was in a team that did this. There were about 6 of us doing this. And then, so you had the team that did the image process, the image transformation. Yeah. My part of it was to then make that all print out on the Canon. So the Canon was a brand new piece of tech. It had an API. So I was writing the code that would then take these image files and do the transformation in the color cube, and then send that output to the Canon to print it. And you can imagine a lot of my early efforts were just like reams and reams and reams of paper with like PostScript characters on them because it hadn't rasterized or whatever. So yeah, huge PostScript files coming out.
And had you access back then to the CMYK specification, the TIFF format, or how you learned how to do that? So
So we had the printout of the TIFF format. So I wrote a TIFF decoder from scratch using the spec that said the header looks like this and these bytes mean this.
So it was work. So you had to work hard, but at one point of time you knew this is doable, right?
Yeah, exactly. And it's one of these things as well. It's very visceral. Like when you can parse a TIFF image, a TIFF file, you feel good.
In C, right? Very good, I would say. Yeah. If you do it in C, then extremely good, right?
I was pretty good at C back then. When you can then produce the PostScript file off the back of that through the RIP, through the raster image processor. So it wasn't PDF. Sorry, it was TIFF to PostScript was the big transformation.
Yeah.
And then taking the PostScript file and converting that into something that you can print on a color printer, and then seeing the actual image come out of the printer is just like, yeah.
Yeah, sure. Absolutely. You see.
So that was my first job.
And you knew Java back then already?
No, Java didn't exist back then. Java came out in 96. So I was an early adopter of Java. I think I probably started using Java in 97, 98. And then in anger, like for a proper job, I was a Java contractor in around 99, 2000 on a J2EE app.
Oh.
And then for a lot of the zeros, for a lot of the 2000s, I joined ThoughtWorks in 2002, and all of my early gigs there were enterprise Java.
And were there any interesting projects or gigs between RIP and Java?
So it was just like, it was a jobbing 20-year-old. So I went to what I call a database marketing company, which was like the if you think of it as the respectable end of junk mail. So they would build statistical regression models of customer data and use that to select people to send mail shots to. So rather than just randomly mailing people, you mail people who are more likely to respond. From there, I went to a big French bank, accidentally saved them 18 billion euros one day.
And you get 1% of it, or?
None of it. I got a thank you.
Okay.
A very senior person came to my desk and said thank you.
Oh, that's very good.
So that was good. Then what did I do after that? I went contracting for a while. I was doing C++ contracting. But again, my first C++ contract, I got the job and didn't know C++. So I was...
And you like C++?
C++ book. I really did. In the late 90s, I really enjoyed it. It gets a lot of bad press. I think there's good and bad ways of writing C++. Bruce Eccles' thinking in C++ was absolutely indispensable. That was like, your Bible on the desk. This was before the STL really stabilized and before a lot of the modern, what we now think of as modern C++. It's a very different language these days. But even back then, I thought it was a great language. I found it very, very... I found going from C++ to Java, I found Java really weird and quirky, and it made some really strange design
For me, the same. Exactly. I really like C++, and Java came out and said, why we need interfaces if we have header files, for instance, right? For me, was a bit crazy.
Well, and certainly what I remember, and I think this might be why I got the job at ThoughtWorks, I remember when J2EE came out thinking this is just a massive con. This is entirely unnecessary and totally over-engineered.
For me, it was completely different opinion, but my suggestion is I invite you back, and we should argue about J2E back then, and of course BDD. This is like second decade, your second decade from your profile, continuous delivery and BDD, and for the listeners,
that was all the ThoughtWorks out years,
yeah. And we're speaking here with Daniel Terhorst North, better known as Den North, a few years ago. And a funny story, you delivered a great keynote. I really enjoyed that. I attended your keynote at WJAX in Munich. And I read the abstract and I said, I know this guy, but I have no idea. The name is somehow strange. Daniel Terhorst North. And I forgot about Den North. And then then after that, I say hello to you. It's again, Dan North was, I just renamed myself. And I say, okay, now it makes sense. Because who could it be? BDD, everything. Why I don't know the guy? And this is great kino. What's going on? And then I recognize you after 1 hour. This was actually the story of November 2025.
Fantastic. Well, I can tell you very briefly the reason for that. So we adopted 2 boys now. We adopted our first son in 2017. My wife's name is Terhorst. She's her father's Dutch. And so we decided that we would all have the same surname. So I was Dan North, and my wife was using Terhorst. North as 2 separate names, and then the boys are Terhorst North with a hyphen. So I started going by Daniel Terhorst North.
Okay.
So that's the story there. And so I still answer to Dan. I still get confused myself.
This is like bottom-up refactoring. What happened, right? If you
exactly.
Yeah,
exactly. It's pool-based.
yeah, perfect. So but it was really for me unreal, because I say, why I don't know you? You know BDD and everything, and I read, and I was like, you are Dan North, because this is the Daniel was confusing. If this would be Dan Terhorst North, then I would know this, but this Daniel was new because for me, right? So it's just perfect. I will re-invite you back. Would be great to talk about the software engineering part, and it was nice chat, and about various things. 1% Java, but this is how it is on the AXFM.
There we go. No, wonderful to speak to you, Adam. Let's definitely do this again.
Yeah, thank you a lot, and see you next time.